In this simple video, I want to give an overview of the Process Analysis 360 tool and how it can be used to simulate a process that it could either be a facility, uh, in a factory setting, or maybe even just a flow chart of an office process. As long as you can assign values to different types of settings, you can use this process analysis tool to actually watch your process unfold. And you can identify bottlenecks, areas of improvement, just process misalignment and timing issues. So I have here in front of me a complex setup, to be honest, but just want to highlight some of the things that can be done with this tool. So here we've got an Autocad underlay that I was actually able to bring in from one of my factory layouts. So that's one of the first capabilities, is that you can bring in data, you can push out data, things like that. You can also add in these different sources and processors and things over here. And so you can start to map out a process saying, I've get some sort of product here. I can process those products and then eventually end up with an output. So as long as you can define inputs, processes, and outputs, you can utilize this tool. So in this example here, I've got a machining group, break and shear machine, and thermal forming. And then different sources are going to be passing materials to those processing stations. And then those processing stations pass their outputs to the assemblers. And there's two sets of assembler stations. And then finally we're going to box up 100 products. So just to show you how this works, we can look at a source here, and the source tells us what the output rate is, which is quite high, and it can tell us the release rate, things like that. We can also look at the transportation. So if I click on any line connecting the input to a process, we can look and see, well, what are we using? A forklift, what's the load times, the unload time, how long is it going to take? So again, this helps us build up a timing for the process. And then different options here, like for example, this is a buffer, which is, think of it as like a loading station. So I take my raw materials, I deliver it to the loading station, and then the operator can bring that into his processing. So here again, what's my capacities, all sorts of things like that. Another little conveyor belt, which takes that material and brings it over. And then the processing station allows us to define lots of different things. So I'm not going to get into all the minutia here, just as more of an overview. But we can look at what is our median time between failures, how long does it take to maintain, what utilization percentages are we looking at, so what defines being underutilized, overutilized. And then here's the meat and potatoes. We look at the process and we say, how long does it take to set up? Is there any variability there? What's the processing time? How many can I produce? And what you end up with is you can take your time study data that you've developed over years and you input it in here, and now we can watch the process. So just wanted to give you a little bit of an overview of where the process is developing a lot of this information from. And now I'm just going to run the simulation. So we'll see right here, it's actually spooling up. It counts out the raw materials that it's going to pass along, and now those end up traveling. So they'll travel to the next station here, and then we'll see that that buffer will be filled up, and we can see what kind of capacities we have here. And then what happens is it takes its batch size, and then it will push that along. So this is going a little bit slow. One of the nice things is we've got a little bit of a speed adjustment here. So I'll turn it up a little bit. And what you can see is that it actually is producing the individual parts here. And so as we produce the parts, it puts it right here. It's ready to move on to the next station. And we can see we're about 8 minutes into the process. So what this allows us to do, I'll speed it up quite a bit more so you can see this a little bit more action-packed. It actually takes the materials and now it pushed it up to the assembly station. So now the assembly station is working. And so we can see about 5 hours into the process, now we've started to make 40. But then the assembler station bogs down, the machining center is not working. So we've got some idle times built into our process which we might want to investigate. So we'll finish up this particular process, and we see that in just under 14 hours, it allows us to complete the 100 products. So what's really nice about the process analysis tools, we can actually watch things flow, but we can also make adjustments. So right now I've got it set up so that the machining group can only pass along one bin of materials. So it can pass one bin at a time. If I was to change that, I might be able to get more output. But before I do, let's quickly take a look at some of the specifics for our process. So if I choose this summary report, we can see here that we have the process set up, and then as we kind of scroll down, we can see some of the utilization. So we've got some inefficiency. The machining group's only running 44% of the time. The assembly stations have a lot of idle time as well. So what we need to do is be able to break up this blocking for machining and get more in assembly. So what I'm going to do is I'm going to go back to my process tool, and let's make some adjustments. So instead of just passing on one cart at a time, let's give the machining group the opportunity to pass 2 carts along at a time. Oops. And so we'll verify that. We'll reset the simulation, and then we'll run it again. Now, because we've already run through it once, I'm going to speed up the timer all the way, and so this should fly through. So we'll let it do its thing. And look at this. It took just under 11 hours. So we actually saved 3 hours. And if we look at the summary report for this process, we can see that we got a lot better utilization. So the machining group now is running 74% of the time. Break and shear is 95. Those poor thermoforming people never get a break. And then the assembly stations are up to in the 70s. So this is a really solid process now. And using that process analysis tool, we can tweak the different components in order to get the results that we're looking for. So again, just as a brief overview of the process analysis tool, if you have any questions, feel free to reach out.